All right, so we're going to take a short detour from flow charting today. Tomorrow we'll come back and we'll work on the full flow chart for that match picking game. But today, I want to talk about some Linux programming. And I posted programming assignment 1. We'll talk about that in detail tomorrow, but it's going to be a program that you write in the Unix shell. So we're going to go over some stuff that will be helpful for that presently. So what is a shell, first of all? You're going to hear a lot about shells and shell programming and the bash shell and all of this kind of stuff. I'm sitting here at a Unix prompt right now, so my prompt, normally the prompt's like a greater than sign or something. My prompt is a little weird. It's a pair of square brackets with a number inside, and the number just sort of keeps track of my commands, and I can go back and I can see my previous commands and stuff like that, so it's a history feature. But for some reason, there's this prompt, right, this 2073 in brackets, and this blinking cursor appearing on my screen, and it's sitting here waiting for me to do something. And if I don't type anything, it's not going to do anything. And if I type something like date, it echoes what I'm typing, but it doesn't do anything. But if I hit the enter key, it shows me the date. And then it shows me a prompt, and it goes back to the blinking cursor, and it's waiting for me. Okay, how is that happening? That's happening because there is a program running on the server whose whole purpose for existence is to listen to my terminal session waiting for me to hit an enter key. Right? And if I type a key, it'll echo it back. And if I hit an enter key, it will look at what I've typed, and it will do something in response. So if I type date with an uppercase D and I hit enter, it'll come back and it'll complain at me. Right? But this is a program, and it's a program called bash. So B-A-S-H, just like it sounds. And bash is an example of what we call a shell. So a shell in Unix is a program that basically interacts with a user session. So it waits for the user to type in some input, hit enter, it does stuff in response to that, generates output usually, and then waits for the user to say something else. And there's a lot of different shells. There's the so-called Bourne shell, SH. There's the C shell, CSH. There's, I think, the terminal control shell, TCSH. And there's bash. This is the born again shell. I'll play on the word born. And this is the shell that we're going to use throughout this course. It's the only one we're going to use. Okay, and that'll make a small difference in a few minutes. So there's a program running somewhere on the system called bash. And in fact, there's a Unix command ps, which lets me show processes running on the system. And you can see there's a process under cmd command. It's called bash. And it's process ID 16554. That's the program that's running right now that's waiting for me to type something in. And if I kill that process, kill 16554, or if I kill it in a really harsh way, which is killing it with a 9, my shell goes away. Right, and now I'm like nowhere. So I'll start a new shell. All right, well, this shell lets us run commands. It lets us say VI to edit a file, lets us say GCC to compile a file, LS to see what files are in a directory, and so on and so forth. But we can actually do programming in this environment. We can do something very similar to what we do when we write a C program, but we can do it and have this shell, this bash program, execute things for us. Okay, so we've already seen some of this, but let's start from the beginning. First thing we can do is we can do output. And the way we do output is we say echo. So if we say echo hello there, it says hello there. And anything that we say echo is just going to echo whatever we tell it to. If we say echo 5 plus 10, It says 5 plus 10. It's very, very literal. But we can have variables in here that can take on values and that we can use as placeholders for other things. So for example, I can say x equals 5. Well, if I say echo x, what do you think it's going to say? It's going to say x. It was one or the other, right? It's just going to say, hey, you said to say x, here's x, right? It's like the math problem, find x, and you point an arrow to x. So if I want the value of x, put a $ in front of it. $sign says, treat this thing as a variable, show me its value. Echo $x, that shows me a 5. So what if I say echo $x plus $x, what do you think it'll say? 5 plus 5. Very literal, except $signs say, show me the value of this variable. If I said x equal to ha-ha, and I echo $x plus $x, ha-ha plus ha-ha. But we could also do more interesting things. We could say x equals $x, and now it tells me x equals ha-ha. So if we want to know the value of a variable somewhere inside a script, we could put an echo statement like that. Well, echoes are good. DOS had an echo command. DOS did not have a cow say command. So cow say is like echo, except a cow talks to you. Very important command. So I can cow say x equals $x, and my cow tells me x equals ha ha ha. So you can use it like echo. And if you look at the manual pages on cow say, you'll see all kinds of other things this cow can do. You can specify what you want the eyes to be made of, and it's got a B switch if you want a bored cow. So you can have a bored cow talk to you. And there's a dragon option and stuff. All right, so we can prompt the user for information. And we can display information, but we want to write something like a program, something where we can say program or my program or main or PA1 or something like that, and have it execute a bunch of instructions for us. And this is the idea of a shell script. And a script, if you've done batch files in DOS, it's the same principle, right? And basically to make a script, so what should we call our program? We called it my program last time. We need a new name.
PA1.
PA1, okay, good. All right, so here's PA1. All right, so we'll argue with ourselves. So we'll say this is PA1, and the cow will say, no, it is not. All right, so normally to execute this, all I have to do is say PA1. But there's a wrinkle here. If I say PA1, it's going to say permission denied. Why? Because if I say PA1 and I execute that, everything inside here is going to get executed by the shell. That's a little bit of a dangerous proposition, because maybe PA1 isn't PA1. Maybe it's the documentation I wrote for PA1, and it's 500 lines of text and talking. And if I start passing all of that to the shell and executing it, I'm executing a whole bunch of Unix commands, and I don't know what's going to happen, right? So by default, you cannot execute shell scripts. Okay, they're set up to be non-executable. And the ls command that you use to list files, that'll take a switch, okay, something that modifies its behavior. If you say -l, it says, give me a long listing. And part of that long listing includes these 10 characters in the front. And these show you the permissions on the file. And we'll talk about this in a lot more detail later, but basically, this is saying that I'm allowed to read and write this file, but I'm not allowed to execute it. That's what that dash means. And other people in my group, people who I've associated with my account, can read, write, but not execute. And the rest of the world can read this file, they can't write it, and they can't execute it. So there's something you can take as kind of a mantra right now, and we'll take it apart later. but the command is chmod, chmod space. The argument you want is 755 space,
What's this one?
and then you want the file name.
Could you just pass it the X flag?
You could, but I like doing the octal.
What is this one?
So this is going to let us execute PA1, or whatever file name is. So this makes file name executable. So if I just created this file name and I try to execute it by saying file name, it'll say permission denied. To fix that, I'm going to say chmod 755 in the name of the file, and then I'll have permission to execute it. So let's do that here. Let's say chmod 755 PA1, and now if I say PA1, it goes ahead and it runs it. So anytime you write a script, you're going to have to do this chmod command once. Right? I can edit it, and it's not going to have to. It's not going to go back to being non-executable. Say what? Yeah. So if you do your ls-l, this change to read write execute. This is read execute. This is read execute. So read write execute. Think of that as 3 ones in binary. That's the number 7. Read -x. Think of that as a 101 in binary. That's a 5. And read -x, that's your last 5. So 755 is really an octal code that's saying which of these flags should be turned on or off. So we can actually set the permissions for reading, writing, and executing in a very nuanced way. But we'll talk about file systems and files in a couple of weeks, and that's one of the things we'll drill down into. All right, so I've got my PA1, I can execute it, and it'll do whatever I put in there. So now, it's pretty easy to make changes to this. So I can add another line that says goodbye, and if I run that, now it's telling me goodbye at the end. All right, so we're off to a good start. We'd like to do input, right? A program that doesn't take any input is basically going to do the same thing every time that you run it, unless there's like randomness in there. So to really make a program interesting, usually we're doing some interaction with the user. We're getting some information, doing some processing, generating some output. Well, we can do that using the read command. So if you say read x, and then you type in something like 23, that gives whatever you typed in as the value of that variable x. So it's like saying x equals 23, but instead the user gets to type something in, and that becomes the value for x. Now if you say read x and you say ha ha, and then you echo the value of x, now x is equal to ha ha.
Since in this case a variable can be both a string or integer or anything, then does it just automatically know if it's an integer or string, and if you like map things?
We can think of it as kind of what's called duck typing, right? So if it looks like an integer and acts like an integer, it's an integer. But in reality, everything is really just a string, right? Even if it's the string 2, 3, it really sees it as a string. It sees it as a set of characters. But we can ask it to treat it as an integer.
So if I told it to add x and x is equal to 5, would it come out with 10, or is it going to add a string?
So let's read x, 5. Right, so if you echo x plus x, it's just 5 plus 5.
Oh, so there's no way to do actual math?
There is, we'll get there in a few minutes, but by default, right, it's everything's literal. Okay, if we say treat x as an integer and add x to itself, right, then it'll give us 10. And if x is ha-ha and we try to do that, it'll actually treat it as a 0. But that's everything we're going to talk about shortly.
So is saying read x, saying x equals?
Yeah. The difference is if you say x equals something, right, that's in your program, it's fixed. If you say read x, you get to specify it when you're running. So let's do that. So let's say, who are you? And then let's read your name. And then let's have the cow say hello, and instead of saying hello $9 name, it'll say hello followed by the value of name, which should be whatever you typed in when it said read name. So now we've got an interactive cow. So who are you? I'm Nick, and it says hello, Nick. All right, still with me? So there's a detail that we need to talk about, and it may not make a lot of sense right now, but I mentioned there's lots of different shells. There's the born-again shell, there's the regular born shell, there's C shell, and so on and so forth. The syntax that we're going to use as we write these scripts varies from one shell to another. And on a Unix system, you can run whatever shell you want. I don't know if it's installed. I can say, nope, it's not installed. I can say sh, and now I'm running a totally different shell. It's called the born shell. It's got a different prompt, and it has slightly different syntax from bash. Okay? And it's possible that a script that I write that works great in bash may not work in a different shell. The read instruction may not be meaningful, for example. So if I'm writing a script and I'm writing it to run on bash, I want to make sure that anybody who says PA1 executes the script with bash, even if they're not using bash themselves. Okay? So there's a trick you can use, which is in the very first line of your program. You put the following: $! exclamation mark /bin/bash. And this must be the first line of the script. And it forces the script to be executed by bash, which is sitting in this directory /bin. So I'm going to do that. And now you've say again?
Bin the directory? Or?
Bin's the directory, yeah. And actually, if you say which bash, it'll tell you where bash is, and it's bin bash. That varies from machine to machine. Sometimes it's /user/bin/bash, but for the server it's under /bin. It's got to be the first line. If I put anything before that, it'll just treat this as a comment. Okay, but if it's the very first line, the shell looks at it and it treats it differently. It says, oh, they want to run this script using this program. It'll make sure this program is running and getting the input. But in general, other than in this case, $! is how we write comments. So anytime it sees a $! in your script, it's going to basically ignore that $! and everything to the end of the line. Which means we can use it to put notations, annotations into our code for our own information, right? To help us know what's going on, or to tell your teacher who you are and what this program is, for example. So let's start putting in some comments, and blank spaces, blank lines are also ignored. So we can put blank lines in there, and I'm just going to make some comments here. And you don't have to do this, but all right, so there's my highly informative comment block here, which should help get me an A. All right, so so let's ask the user to identify themselves, and we'll say echo who are you and read name, and then respond with a greeting. So those aren't really useful comments, but you get the idea, right? I'm basically saying, what is this block of code doing? What's that next block of code doing? And so on. Get in the habit of putting in comments, okay? You gotta get in that habit, because you'll start getting dinged more and more throughout the courses. By 223, if you're not doing good commenting, it's going to be big deductions on programming assignments. And industry is coming back to where they're putting a lot of emphasis on coding style and internal documentation. So it's a good habit to get into. And you're commenting primarily for yourself. So this is a simple program, but imagine a 5,000 line program written in C with pointers and stars and ampersands and 100 variables and all this kind of stuff. And you find a glitch and you find that to correct it you need to do like ++I instead of I++, right? Throw a comment in there and say what you're doing and why you did this and what happened before you made this change and so on and so forth. Because you'll come back in 6 months or a year and you'll try to figure out something about that piece of your code, and you can either go through the whole process of debugging it again or you can read your comment, right? So we'll see this more as we get into more programs. Yeah?
What exactly is counseling? Another program or?
Yeah, so good question. So let's say which Cause, user games Cause, it's a program. And if you look in user games, there's a few games in there. I don't think Endless Sky is actually on there. But there's Rogue. How many people here played Rogue?
I've heard of it.
Forget I mentioned it. That's okay. It's not at all addictive. Oh yeah, and there's Cowthink. So you can have a thinking cow too. All right, so commenting. So, and this does exactly the same thing as our previous version, right? The comments are purely for your own information. They don't affect the behavior of the program, except in the very first line of your program, if your comment is beginning with an exclamation mark, that says, what program should I use to execute this script? Other than that, number sign, everything else is ignored. All right, well, so what about arithmetic? So x equals 12, echo x plus 1, and it says 12 plus 1. Amusing, but not what we want. So sometimes, even though x is just the character 1 followed by the character 2, we want to treat it like an integer. And there's a slightly quirky way to do that, which is to say $, parentheses, parentheses, and then put in some expression in here. And that will cause a shell to say, okay, this is supposed to be arithmetic. Let's go ahead and actually do addition and multiplication and so on and so forth. So x equals 12, if I say echo $paren, x plus 1, there's my 13.
I'm kind of surprised the $sign is on the outside of it.
We could put it on the inside also, but it's the one on the outside that's making this work. We could also say $x, but it will assume that things in here are variables, things inside the parentheses.
How come just one parenthesis doesn't work?
Well, sometimes it will, but sometimes it won't. And I don't have a good explanation for why it has to be 2, but there is a good one. We're doing a whole lot more than I'm describing here, right? We can think of this is how we do arithmetic, but we're actually running something called eval somewhere in the background, and there's some handoff between where different things are evaluating this, and it gets really, really deep as far as rabbit holes go. And this brings up the next important point, which is there are a lot of different ways to do any given thing in Unix or in a shell script, okay? There are other ways that we could evaluate x plus 2 or x times 2, okay? There's an expr command, I believe. There's something you can do with a square bracket. There's lots of ways to do this. And everything that we do when we look at if statements, when we look at while loops, there's multiple ways to do those, okay? So here's my bargain for you, right? If you're already familiar with shell scripting or a Unix environment and you have your favorite way of doing arithmetic, of doing if statements and things like that, you're welcome to stick with that. I'm not going to say you've got to do it the way that I'm talking about, okay? But if you're learning this for the first time or refreshing it, I'm going to be as consistent as I possibly can. I'm always going to try to do if statements exactly the same way. I'm always going to try to do arithmetic exactly the same way. And if you learn to do it this way, I'm not saying it's the best way, but it's the way that will mesh with what we're doing in lecture, with what you'll have in your notes from class, with what you'll see on the video recordings. Okay? If you go to Google one night and say, how do I do an if statement in Bash, chances are you'll find a different syntax for it. Okay? And that will still work, but it's not going to correspond to how I'm going to be doing things up here. And it's probably going to end up being more confusing. Because you'll see sometimes I use one square bracket, sometimes I use two square brackets, and you're not going to know which is which. And if you use a different style from what I've been doing and it ends up not working, right, if it's wrong on an exam or something like that, you're going to lose points. Okay? If you try to do it the way that I've been showing it and it's not exactly right, but there's one small issue, right, I'll give you partial credit for it and so on. So you got a better chance of getting partial credit if you sort of stick to one style. Along those lines, right, spaces matter way more than we're usually comfortable with modern languages. And Bash in particular is just super picky about syntax. So again, I'll try to be very consistent. And unless I mess up, which does happen, right, what I show you and what I describe should always work.
Here's a question.
Oh, yeah.
Yeah, does the textbook follow the same text, like if we...
It includes it, but it also covers other...
Okay.
Yeah, so that's a much broader set of Unix than what we're going over here.
Do you have like recommended reading out of like the textbooks that you would recommend, so that we can know which parts to focus on?
Take some notes on what we're doing. It's basically if statements, while loops, for loops, evaluating expressions. That's pretty much it.
Can you do modulo in this?
Yes, you can, and that's a glorious thing. So let's do x% 4. So x was equal to 12. Let's set x equal to 13. Echo x% 4. It's a 1. There's your remainder. That may help you in a few days, right?
How do you guys send the Bash thing?
We're in Bash right now. When you log into the server, you're already running a Bash shell. Right, so there's a Bash program running on the server right now, and it's already, so I logged into linuxengrcs.com, and once you log in, the server starts a Bash program and connects it to your terminal, basically.
Okay.
So it's already there, it's already running. And whatever I type, it's being executed by Bash. If you make a program, right, you just say !bin bash, and this will get executed by Bash when you say PA1, or whatever the program name is.
There's one small thing that's confusing.
Okay.
So, if, let's say you're doing C, you type in VI in the main program, and you can't type anything until you hit I. But when you were just doing it, you were able to type right away, typing I, basically use the same command of VI in the main program.
Well, how do you know I didn't type I?
I guess I just didn't see that.
Yeah.
Okay.
No, I did.
Oh, okay. So it's the same exact screen you're getting, it's just instead of typing C, you're typing Bash. That's all it is.
Yeah.
Oh.
Yeah, so VI is just the editor, right? And it doesn't care if you're making a text file, a shell script, a C
Okay.
program. It's completely agnostic to
That's
that.
confusing me, because I thought VI was just for C.
No. VI is just a text editor,
Okay.
right? It's basically Notepad. And you can do anything that you want, and it's just a file.
Yeah, since some of the naming basically a formality for the file can really be whatever it wants.
And the file can kind of be whatever it wants. So, I mean, I could call this pa1.bash. I could call it, pa1.c, And then if I say PA1.c, it's running my shell script, right? Don't call your shell scripts .c because it's confusing, but shell doesn't care, right? Type in a file name, it'll look for it. If it's executable, it'll execute it. All right, so let's talk about if statements. So to have a general purpose programming environment, you need three things. You need to be able to execute sequential instructions. We can do that. We can just list them in a shell script and they get executed one after another. You need to have conditionals. You got to be able to say if then, and you got to have looping. If you got those three, you're what's called Turing complete usually. You can write any program that you can write in any other language. So let's talk about conditionals. Kind of looks like what you would expect from C, but again, super picky syntax. So if space, bracket, bracket, space, condition, space, bracket, bracket. No spaces between the brackets. Separate line, then, separate line, stuff, separate line, fi, which is if spelled backwards. That's the end of the if statement. So this is like the closing curly brace, and then is like the opening curly brace.
Two square brackets.
Two square brackets with no space in between them, but spaces on either side. Yeah,
I missed, what was the fi mean?
that's the end of if.
Okay.
So it's like it goes with the then.
So then do line right underneath that.
Yeah, then's got to go on a new line.
It had to be right underneath it, there's space like to move.
You can, I think you can have blank lines, yeah. And leading spaces are ignored. I'm usually going to indent when I'm inside an if statement so that it's easier to read. And you can also say else, other stuff, and then put your fee down there. So there's a basic if then else.
And this means stuff can be multiple lines, right?
And it can be multiple lines, yeah. So here again, there's other ways to write an if then else statement, right? If you only want one line of stuff, there's ways you can change this. If you want then to go on the same line as the if, there's ways you can do that. But I'll try to always stick to this, okay? I'm lazy, okay? I don't know if I've told you that in other courses. I'm really lazy. I don't like thinking except for things that I want to think about. So when I'm writing a program, I don't want to try to remember syntax, okay? I want to worry about what it is that I want this program to do. How am I going to do it? I don't want to worry about, should I put this here? Should I put that there? I've only got one thing in my else statement and so on. So I learn a way to do something, and I just use that, right? That's just me, but it lets me save my cycles for the stuff that I actually want to spend my brain power on. So let's use this. So hello, welcome to the secret file program. Enter the secret code. And then let's read the code from the user. All right, so we're going to write a script that will give us some secret message, but it will only do it if we know what the secret password is. Yes?
You mentioned ifs and else. Can I do else if?
I think it's ELIF for else if. Yeah, thanks. Okay, so we're going to read a secret code, and now we're going to see if the code is correct. So, if bracket bracket $ code comparison to equal sign, same as C. So what should our secret code be? 1, 2, 3, 4. See, you're better than the last class because they did 1, 2, 3. They've got lax security practices. Okay, so if $ code equals 1, 2, 3, 4, then welcome. Casway. Welcome. What are your instructions? Else and a fee. right? So sort of the most simple if then else example. Read the code. If it's 1, 2, 3, 4, we'll get a welcome from the cow. Otherwise, we'll get told that we had the password wrong. So let's run that. PA1, welcome, enter the secret code, 1, 2, 3, 5. Oh, bad password, goodbye. Okay, PA1, enter the secret code, 1, 2, 3, 4. Hey, we got in. Make sense?
What if you want to echo the word echo? Does that work?
Let's find out.
Okay.
It's way more literal than you can believe.
So even if you like had echo further in like a string of text, it would still
Yeah.
mess it up. Okay.
Yeah. We can say echo rm PA1, and it doesn't remove PA1, it just says rm PA1. But here's something weird. Echo $sign. I mean echo asterisk. That does something kind of weird. So stay away from asterisks and question marks for now. We'll see why in a bit. All right, so there's basic if then, right? And let's try else if. I don't know if I got the syntax right. So if code is 1, 2, 3, 4, that's good. If it's 1, 2, 3, we'll say that's good too. Otherwise, we'll say bad password. And I might have that else if wrong, but we'll take a shot at it. So PA1, 1, 2, 3. Oh, that's good too. 1, 2, 3, 4. And 1 is bad password. Yeah.
So it's sort of similar to like the text-based games that you like in the past where you like enter your things
Mhm.
and new different.
Yep. Yeah. That's all you need to do that. And we're like 2/3 of the way to a full programming environment now, right? We need looping. We'll do looping tomorrow, but once we have while loops, then we've got a full-fledged programming language. And this is so much quicker to develop than, say, a C program, right? Trying to do this in a C program, ignoring the difficulty of cowsay, where we gotta use printfs and all the stuff that entails, and \ns, and we've got to use scanfs and %ds and ampersand variable names and things like that. And shell script is right, pretty straightforward, right? So this is really good for rapid development. And PA1, right, is going to be your stick-picking game done as a bash script. So it's going to be easier than doing it in C. Doing it in C is going to be the second programming assignment. But for working out the algorithm and some of the details of how you want to deal with certain cases, right, shell scripting is just like a really quick, get on the air as quickly as possible kind of thing. On the other hand, right, really, really picky syntax. So I took out a space here before $sign code, and now it's complaining to me. And I think if I do the right code, it's going to say bad password now. Right. So just this one little space right here makes it work. Take it out, it stops working. And a lot of the syntax is really, really, really picky. So I don't even think about this as anything other than if space, bracket, bracket, space, condition, space, bracket, bracket. Like peanut butter and jelly, it's just a thing. All right, so we've got if statements. This works fine. This does exactly the same thing. Putting hello inside double quotes. But it's a little better to do this, right? To put it inside double quotes. And it's a little hard to explain why at this point. But when your script is being evaluated, right, when it sees $code, it basically replaces that with whatever the value of code is. And if code is, 1, 2, 3, 4, this statement basically becomes if 1, 2, 3, 4 equals 1, 2, 3, 4. But sometimes it's possible that somebody types something in, and when $code gets replaced by that something, it generates a syntax error. And let me just give you an example. This usually doesn't happen anymore. So pwd is a command, date is a command. If you separate them by a semicolon, it executes both commands. So you can put multiple commands on a line. Okay, so consider this. Here's a simple script. Echo, who are you? Read name. Echo, hello, $name. Pretty straightforward. Prompt the user, get their name, greet them by their name. What could go wrong? So you've got this running on your server, and you've got a web page, and this is going to interact with a user, right? And it's going to say, who are you? And they're going to type in their name, and you're going to say hello name and send that back to them. So somebody runs this, says, who are you? And you say, my name's Bob, and it says, hello, Bob. Great. Okay. Somebody else comes along and runs this, and it says, who are you? And you say, my name is Nick, semicolon, RM, space, asterisk. Well, what happens in this echo statement? $name gets replaced by this. And now the shell executes the following. Echo, hello, Nick, semicolon, RM, star. And this is two commands. First it's going to say hello Nick, and then it's going to delete every file in the current directory. So this is an example of code injection. Now bash has been locked down so that it won't let you actually do this, right? It won't go ahead and just sort of blindly execute that command inside the echo statement. But there was a time when this was a real danger, okay? This is also something called SQL injection. If you read XKCD, look up little Bobby tables. That's the classic on code injection. So we can avoid this possibility by simply throwing in quotation marks. Right? These don't matter, but down here we say echo quote hello $name. Well, now if the user types this in, what's the command that's being executed? Echo quote hello Nick semicolon RM star. And when you say quotation mark something and quotation mark, all that stuff inside is treated like one string. So this is really just saying echo this big long string that has some weird stuff in it. So we usually want to be in the habit when we're using variables, unless we're really sure that we don't want to, we want to put those things inside double quotes.
So, am I correct in assuming that when this was first being a thing, when you set up the basic Jimmy password setup, someone could just make their username Nick semicolon RM after just delete everyone's stuff?
Basically, yeah. Not exactly that easy, but yep, that's the idea. Yeah, go ahead and Google. Not now, but little Bobby tables. It's an XKCD where the parents name their kid like drop table such and such, and then the admissions office like lost all their database. All right, so and x equals 12, echo $x is 12, echo quote $x is 12. It does no harm. Okay. On the other hand, if you use single quotes suppress the evaluation with dollar signs. So if you want to print a dollar sign, you can say echo single quote dollar sign, and that'll come out fine. Yeah. So. And I don't think it works like this, though. Yeah, it does. Okay, cool.
C, where if you want to have quotations show up, it's that side.
Yeah. You'll see me do this a lot when you ask questions. I'll just like try something. That's a really good habit to get into too, right? If you're sitting in a council shell, right, and it's like, well, what happens if this happens? Well, don't try deleting all the files or making a fork bomb or something. But within reason, if you're curious on, well, why do I have to have this? What if I don't? Give it a try, right? This thing has got all the answers inside it. And if you can get experience at finding those answers and pulling them out, right, there's no stopping you, right? The sky's the limit.
I guess this is probably a dumb question, because assuming not, but is there any danger at all in if we're on the server and just typing random stuff?
There's a few ways you can get into trouble.
Okay.
But usually you have to work pretty hard. Now you can get into trouble in your own directory, right? So you can say rm to remove a file. And if you say rm-r, it will recurse from your current directory down to all subdirectories. And if you say star, it will delete all files from your current directory on down. But it'll ask you about things based on permission and such. But if you say rf, it says force the removal, and anything that you have permission to remove will get removed, right? So if you're curious about that, don't do it in your top level directory. But as far as the health of the server, if you want to crash the server, it's pretty easy to do, okay? And then we'll have a conversation. But if you're not trying to do something malicious, you're probably pretty safe. When we talk about process control and forks, we'll talk about the things to avoid. But yeah, most of the danger is just to your own stuff.
So if you made a bash script that just opens itself?
Yeah, if you made a bash script that kept running itself. Now, I think I set your process limit to like 20 or 30 processes, so that should shut it down, but sometimes I relax that for some reason. All right, anything else we need to say here? We got a minute left. Yeah, so let's just clean this up. Let's just put these in here. Right, and so on. All right, so there's some nice clean code. And now it'll behave the way we expect, hopefully. All right, so tomorrow I want to talk about if statements, one other aspect, which is working with numbers, right? Because we can say equal, equal, or exclamation equal for equal or not equal. But if we want to know is one number bigger than another, we got to do something different. So I want to talk about doing comparison on numbers. I want to talk how we can use this to tell whether or not something's actually a number or something that's not a number. And then I want to talk about looping. Then we'll go over PA1 and get you going on that.